चलो ये स्टार्ट कर लेते हैं अभी। अच्छा, last time we did the electrochemical cell. वो कहाँ पे? Where's the data booklet for? So we did the electrochemical cell and you just connect two electrodes together. ठीक है, that's what we did. You connect two electrodes. So you connect two electrodes together, which are half cells, or simply electrodes, or you get a complete cell. And when you connect two electrodes together, what happens is that the electrodes are at different potentials. Okay, one of them, the lower one, and there's a higher one, the electrons would start flowing towards the higher potential from the lower. The lower likes to lose electrons, and the higher one starts to gain electrons. It gets basic equilibrium. Electrons will come towards it, and if the quantity of electrons increases, the equilibrium would shift forward. The electrons over here will decrease. So if the electrons decrease, the equilibrium would shift backwards. So the lower potential, basically, this is something that we did earlier as well, right at the beginning. The main point is that the lower potential loses electrons and the higher potential gains electrons. So one of the equilibrium shifts to the left, gets oxidized. The other one shifts to the right, gets reduced. And you can write down the equation and you can come up with the whole reaction. And the E0 cell helps you to determine which how fast the reaction is going to happen. For example, if the potential difference is very large between the two electrodes, the E0 cell is very large, then that means the electrons would flow very quickly. Okay, so I said the E0 cell, like physics, is just simple higher potential minus lower potential, but technically it's reduction potential minus oxidation potential. So if you have a very large E0 cell, that means the reaction will happen very quickly. Small E0 cell, the reaction is not going to be very feasible. Okay, so ये सारा तो clear है ना? Is this all clear?
Yes.
अच्छा, one thing that we still missed. One thing that we still missed. 1 second. Was okay. One major thing that we missed was what was the purpose of the salt bridge, right? So I'm going to discuss salt bridge now. Now imagine that the equilibrium starts to shift backwards, right? Na starts to lose electrons. It becomes Na plus 1. So more and more Na plus 1 ions will start to form. So the solution will have the quantity of Na plus 1 ions will start to increase. And the solution will have more and more positive ions. Now, the reason the salt bridge is necessary is without the salt bridge, current will not be able to flow. Imagine that there are more and more sodium ions getting produced. If there's a lot of positive charge in the solution, positive ions in the solution, what will happen is that the electrons over here will start getting attracted back to the positive ions. So the electrons will not be able to flow to the other side. So the current will stop. Because if the electrons are to flow from the lower potential to the higher potential, then there should not be a lot of positive ions in the solution. Again, as the reaction proceeds, more positive ions are being produced. So the amount of sodium ions will continue to increase. So what this salt bridge does is that it's kind of a diffusion channel. That if you have too many positive ions, the positive ions will start diffusing into the salt bridge. And they'll get absorbed by the salt bridge. So that is why current flow will continue. Otherwise, current flow will not continue because there would be too many sodium ions produced, and the sodium ions, positive ions, will start attracting the electrons back. Okay, बात समझ आइए? Jan, Alicia, Anna, is this clear? See. And the same, and a similar thing kind of applies to the other side as well. Okay, what's happening here? The copper ions are turning into copper, right? So slowly what will happen? all the copper ions will start turning into copper, right? So the copper ions will, so there'll be fewer and fewer copper ions. So who's attracting the electrons? Who's gaining the electrons? The electrons are coming from the other side, and they're supposed to be gained by the copper ions, right, in the solution. I mean, if you look at the equation, that's what's happening, right? So if there are no copper ions, no one is sitting here to gain those electrons. So what the diffusion channel would kind of do is, what it would kind of do is that it will have copper ions in it. So if the quantity of copper ions decreases, more copper ions would be able to diffuse out of the salt bridge, and so that there is always someone present. If the electrons are coming in, someone is still there that's gaining those electrons, right? So the salt bridge kind of balances the ions out, because as soon as the current flows, the ions, एक ion ज़्यादा produce होना शुरू हो जाएगा, there would be too many sodium ions, and the other ion would decrease in quantity. ठीक है. Can you write your name? So ठीक है, message me after class. I'll try and message you, ठीक है? But leave a message there. I mean, leave a message on WhatsApp. Just any message. Just say hi, ठीक है? So I know who to message. अच्छा चलो ठीक है, वापस इस पे आ जाते हैं. We've got अच्छा, everyone, is this clear? You don't have to go into the details. Remember, the salt bridge is necessary for the current to flow. Otherwise, too many positive ions will be produced over here, and the electrons will not be able to go to the other side. And there would be too few positive ions on the other side, and the electrons will not be, no one would be gaining those electrons. So that's why the salt bridge is necessary. Beyond this, you don't need to know much. Just remember that the salt bridge is necessary for the circuit to complete the circuit. ठीक है? चलिए ठीक है, ये clear है, और that's all about salt bridge. ठीक है? Now, in pretty much all electrochemical cells, the same concept would be applied. You'll be asked to draw some of them. Okay, I just showed you. We've already done that. So we'll do more past paper questions. We'll do more of those questions now. All you've got to know, all information that you need. Now forget the drawing. Now we're going to move past drawing. Okay, we're not going to do drawing anymore. Okay, we're just going to directly answer the question. Lower potential loses electrons, higher potential gains electrons, and the E naught cell determines, the potential difference determines how fast the reaction is going to happen, right? So that's it. That's the basic thing that you need to know. So for example, now without drawing, ठीक है, no drawing. यहाँ तक तो clear है ना everyone? Is this clear, Abdullah? Alicia? Is this clear, all of it, including the drawing?
Yes, sir.
So no more drawings now. ठीक है, higher potential gains, lower potential loses. E naught cell determines how fast the reaction is. So predicting redox reactions now directly without drawings. So predicting redox reactions. So for example, I'm going to take two random equations from the data booklet. Completely two random equations. Let's take this one. बल्कि दोनों को उठा लेते हैं. Just a second. अच्छा, so this one, two equations in front of you. So who's going to gain electrons? Higher potential gains electrons. So higher, that means it's going to gain electron. This one is lower. This one loses electrons. So higher gains electrons. That means the first equation would go in the forward direction. It's going to gain electrons. And the lower one, relatively the lower potential, loses electrons. So this one would lose electrons. And that's it. You figured out that if you put iodine and potassium together, you now exactly know who gains electrons, who loses electrons. That's about it. And you just have to make the overall equation now. So iodine is the one that's gaining 2 electrons to form I minus 1. And potassium is the one that's losing electrons, potassium plus 1. Now the electrons gain and loss have to be equal, so I'm going to double this, multiply this by 2. So it's going to be 2 electrons. So that means 2 electrons are gained and 2 electrons are lost. Add up the 2 reactions, the reactants and the products, and so it's going to be I2 plus 2 potassiums and the product would be 2I minus 1 plus 2 potassium plus 1. So you've figured out your redox reaction. That's about it. Okay, it's very easy. High gains, low loses. That's it. And now the E naught cell would be high. It's the potential difference, higher potential minus lower potential, or reduction potential. This is 0.54 is the reduction potential, the one that gains electrons, minus the oxidation potential. So that's minus 2.92. So can anyone tell me what the value you're getting for this? क्या आ रहा है, किसी ने किया? One second. अच्छा, 3 point. I was getting 3.46. So kind of easy, but there's one problem with this, and that is, okay, how did we exactly know? Now there's going to be a problem with this. I mean, this is simple. High gains, low loses. There's nothing to it. There's going to be a problem when you have, let's say I do another example and you'll see what the problem is. Let's say there's a question now, because the question is not going to be that straightforward. So I'm going to write down a few steps now. So let's say somebody's asking me what will happen if Fe reacts with, copper reacts with FeCl3. Okay, now listen to this carefully. So the question is, what will happen now? A problem यहाँ पे कि there are multiple electrode reactions. Like you got copper over here. So the question is, what will happen to it? Whether it will form 1+ ion, whether it will form, because you've got multiple options for copper. Like if you look over here, can't get copper. If you look at copper over here, you got copper over here. Copper in equilibrium with copper plus 1. Copper might lose electrons to form copper plus 1. But you've got another reaction as well. You got another copper, and it could also turn into copper 2+. So you've got 2 options for copper, right? So sometimes what will happen is you'll not have one electrode reaction. You'll have multiple electrode reactions, and you would have to figure out between them, like what's going to happen between them. The same applies to if I react, it's reacting with Fe3+. Fe3+ over here. So if you look at the equations over here, you'll notice that Fe3+ has multiple equations as well. Fe3+ can gain 3 electrons, and form Fe. There's another one as well. Fe3 plus can gain one electron to form Fe2 plus. So now the problem is that most reactions are not going to be as simple as this one. Because iodine ki to ek equation thi na, there was no other equation. If you look at iodine, it's there's only one equation, just this one. Iodine forming I minus 1. Potassium only had just one reaction or one possibility. There was only one possibility that potassium could turn into potassium plus 1. But now you've got multiple possibilities. Multiple things can happen now. So यहाँ पे questions like these things can get slightly more complicated because there are multiple possibilities. So it's not going to be as simple as this one. So the steps for this is, step number 1, वो ये कि first identify the reactants. So we have to identify the reactants, specifically the ions. Like in this case, we've got copper, which is a neutral metal. But FeCl3 is not one thing, because you will not find any equation for FeCl3. Just NaCl is not one thing; it's Na plus 1 and Cl minus 1. Similarly, FeCl3 is Fe3 plus and Cl minus 1. Okay, so don't think of FeCl3 as one entity. It's actually two things. It's Fe3 plus and Cl minus 1. Maybe Cl minus 1 might turn into Cl2. Maybe Fe3 plus turns into Fe2 plus. So identify the ions first. That's the first step. Actually, now clear. See, Belisha, is this clear? Abdullah, clear? So you move to step number 2. Okay, we found. So step number 2. Now every species has multiple possibilities. Copper could turn into copper 1 plus. Copper could turn into copper 2 plus. Same with Fe3 plus. So what you're going to do in step 2 is identify or write down So we're going to write all possible electrode reactions, all possibilities that can happen to it. So all possible electrode reactions. So starting with copper, I've got 2 of them, copper plus 2 turning into copper. And the E naught for this is 0.34 volts. So remember, I'm going to write all possibilities involving copper. And always remember, these are reversible reactions. So the reaction could be going in the backward direction or it might be going in the forward direction. We haven't figured that out yet. Okay, so right now, this is a reversible reaction. It can go in both directions. I haven't figured this out. So this is the reaction for copper, and there's another reaction for copper where it's in equilibrium with copper plus 1. So you've got copper plus 1. And it's in equilibrium with copper. So there are 2 possibilities, and I'll check the E naught for this. Copper plus 1, yahan pe. Copper plus 1 in equilibrium with copper, that's 0.52. The other one is 0.34. So this one is this one is 0.52 volts. So then I'm going to do it for Fe3 plus. So the first one, I've done it for the first one. I've written down all possible things that can happen to it. I'm going to move to the second one, the Fe3 plus 1. Okay, there's 2 possibilities. It's either Fe3 plus So there are two possibilities. One is Fe3 plus gaining electrons, 3 electrons to form Fe. That's one electrode. The other one is Fe3 plus gaining just 1 electron to form Fe2 plus. And this one is E naught is 2.77. As it's 0.77, the other one. I don't remember. That's Fe3 plus this one. That's minus 0.04. To get this one. As this one is minus 0.04. And then the last one, we've got a Cl minus 1 as well. So we've got a Cl minus 1 as well. So I'm going to write down the possibility for Cl minus 1. What could happen to it? If I go back and have a look, Cl minus 1 is somewhere over here. That's this one. We've got Cl minus 1, and that's 1.36 volts, in equilibrium with Cl2. So let's write down that one as well. So I've got Cl2 plus 2 electrons in equilibrium with 2 Cl. And that's E naught 1 point. That's 1.36 volts. So I've written down all. Now you don't have to actually write it down, because if you have the data booklet or the table is given to you, you just mark it on there. Okay? So you don't have to waste time writing this every time. Okay? You can just put a mark on all those equations that are relevant to you. I said write down, identify all possible electrode reactions involving your reactants only. The reactants that you have, only those reactions. Because I did not write one Cl minus 1 equation. The reason I did not write this one, there's another equation for Cl minus 1. So the reason I did not write this equation was that Cl minus 1 has to react with an OH ion in this electrode. I don't have OH ions in my solution. Like in my reactants, I don't have OH ions. So if I had OH ions, then Cl minus 1 reacting with OH ions would work. So remember, you're only going to select those equations which contain your reactants and your reactants only. For example, Cl minus 1 alone, it can obviously lose electrons to form Cl2, that's fine. But Cl minus 1 reacting with something that you don't have, like OH ions, that is not a possible electrode reactions for you. So yes, our clear step number 2. Is this clear? I said step 3, that's the final step. That's where you figure out, what's the rule? Higher potential gains electrons, lower potential loses electrons. So you're going to figure out who's the highest potential. So higher E naught gains electrons, and the lower E naught gets oxidized, loses electrons. But you have to make sure it's your reactants that are losing and gaining electrons. It has to be one of these three. कोई चौथी चीज नहीं होनी चाहिए, because these are your reactants. You have to, someone between them has to gain electrons, and someone out of these three they have to lose electrons, right? So it must be your reactants that are which are losing or So it's got to be, it must be your reactants that are losing or gaining electrons. Has to be one of them. It must be your reactants losing or gaining electrons. Which one is the highest potential at the moment? That's 1.36 volts. I'm going to try and figure out who gains electrons. So right now, the highest potential, that means this is the one that's going to gain electrons. It's going to go in the forward direction. That's the highest. But I can't use this equation. Again, the reason I can't use this equation is because it's Cl2 that's gaining electrons. I don't have Cl2. In my reactants, I don't have Cl2 anywhere. Okay, so the reason I can't select this equation is no Cl2 is present. Although it has the highest potential, it's supposed to gain electrons, but there is no Cl2 in my reactants, which is why I'm going to completely get rid of this. It doesn't work with my reaction. Next one, who's the highest potential now? The highest potential now is this one. So the highest potential gains electrons. So it's going to go in the forward direction. It's supposed to gain electrons. And it works perfectly fine because I do have Fe3 plus. So what all my equations are stating is that Fe3 plus has the highest potential. So that's the one that's going to gain electrons. So I'm going to mark this one out because that perfectly works for my reaction. That for me is the one that has the highest potential. ये clear है, समझ आया? Is this part clear? Shihan, Naseeb. So I figured out who's the highest potential. That's the one that's going to gain electrons. And now I'm going to figure out who's the lowest potential. The lowest potential is the one that loses electrons. So who's the lowest? The lowest at the moment is the Fe1. Okay, that's the lowest. So that's the one that loses electrons, right? But we don't have Fe. Look at the reactants. We don't have Fe. We have Fe3 plus. We don't have Fe. So that means I can't use this equation. There is no Fe present in my reactants. So I'm going to cut this equation. As I'm removing that, who's the lowest potential? It's 0.34, I guess. So copper is the one that loses electrons. Do we have copper in the reactants? We do have copper. So that makes perfect sense. So I figured out who's the lowest potential. That's this one. And that is what I wanted to figure out. So the problem with this reaction was, so let me just repeat. The problem with this reaction was that multiple things could have happened to copper. Copper could have turned into copper 2 plus, copper could have turned into copper plus 1. So you weren't dealing with just one electrode. Fe3 plus could have gained 3 electrons, Fe3 plus could have gained just 1 electron. Same with Cl minus 1, something could happen to Cl minus 1. We wanted to figure out, so I wrote down all possible electrode reactions involving copper, only copper, just copper, neutral copper. And I wrote down all electrode reactions that involved Fe3 plus, but only Fe3 plus. I did not write equations involving that did not have Fe3 plus. Like I did not write this reaction. I had Fe3 plus in my reactant. So I wrote down all possible reactions that only involved Fe3 plus. This one over here, it had Fe3 plus, something happening to Fe3 plus. So I wrote down all reactions that involved these particular ions. Usme I figured out higher potential gains electrons. This was the highest, the Cl1, but I ignored that because there was no Cl2 in my reactants. If I removed that, the highest potential was for Fe3 plus. That means I do have Fe3 plus, so that means that's fine. That's the highest potential. This is the lowest potential. Now, once I have these two potentials, I can make the overall equation. That's, I figure out who gets oxidized, who gets reduced. So the overall equation will be, क्या होगी overall equation? That's the copper equation. ठीक है, the lowest one, copper, and copper is turning to copper 2 plus 2 electrons. And then you have the Fe3 plus equation. Plus 3 electrons, and that's not 3 electrons, 1 electron. That's turning to Fe2 plus. Make the number of electrons gained and lost equal. So multiply this by 2 Fe and the products that you're going to have is copper 2 plus plus 2 Fe2 plus. So after all of this effort, you've been able to figure out what your final equation is. And after all of this effort, you've also been able to figure out the E0 cell. That's a reduction potential minus oxidation potential. That's your E0 cell. That's 0.77 minus 0.34. That's 0.43 volts. The Fe3 plus 2 electrons is not a reaction. There's Fe3 plus 3 electrons, there's Fe3 plus 1 electron. So I guess Fe does not like to gain 2 electrons because they did not give that as an option. Okay. So basically, I'm just going to write those reactions that are available in the data booklet. There could be thousands of other reactions. I mean, I guess there might definitely be actually Fe1 plus never really forms. Fe1 plus as an ion is very unstable. So which is why that reaction is not there. So trying to do this quickly, remember we just wasted time all of doing this, right? So I'm just going to try and do this on the data booklet now. Everything from scratch on the data booklet. I had copper, so remember things would be a lot quicker on the data booklet. So one of my reactants was copper. Try and figure out all your copper equations. So here's copper. Those are your two equations. The other reactant was Fe3 plus. Find out where Fe3 plus is. Whether it's on the left side, whether it's on the right side, doesn't really matter at the moment. So Fe3 plus, right? And then I had Cl minus 1. So Cl minus 1 is over here. So I've got 1, 2, 3, and 4, 5 possible reactions. The highest one gains electrons. The highest one is this one, 1.36, right? And I'm going to underline my reactants. That's Cl minus 1. I have copper. I've got Fe3 plus. So what's the rule? The higher potential gains electrons. 1.36, that's the highest. So this is the one that's going to gain electrons. But it's not my reactant that is gaining or losing electrons. It's someone else that's gaining or losing electrons. So that I'm going to cut that out. Ignore that. Out of these 4, who's the highest potential? That's coming out to be 0.77. So this is the one that's going to gain electrons, right? And you can clearly see it's one of my species that is gaining electrons, one of my reactants. So that's fine. That makes sense. So I figured out who gains electrons. I'm going to figure out who loses electrons. So lower potential loses electrons. Minus 0.04 is the lowest. Well, if I take that as the lowest, then Fe is the one that's going to lose electrons, which I don't have. So ignore that. Who's the lowest now? 0.34. That makes perfect sense. That's the one that's going to lose electrons. So copper is the one. Copper, I do have copper with me. So I figured out my equations. That's one of them is this one, the one that's losing electrons, the other one that's gaining electrons. Okay, is this clear? But उधर मैंने सिर्फ steps लिखे, लेकिन in an actual exam you just do all the working on the data booklet. That's it. Or the table would be given to you. Just work it out on the table. Okay. So we'll do a lot more questions on this. Okay. This is something important. So we'll practice a lot. Okay. If in next class में करते हैं. So okay everyone. Love this.